In today's video, I'm going to give you a lovely intro to probability as it pertains to grade 12, where you learn counting principle, factorials, those kind of things. And so factorial, what is factorial? It's that little exclamation mark that you've never used before in your calculator, and it just means if it's 4 factorial, it's 4 times 3 times 2 times 1. Each time the options always just get one less. If it was 5 factorial, it's 5 times 4 times 3 times 2 times 1. So keep that in the back of your mind for just what it is. So I've given a few examples here. There are 5 swimmers in a race. How many different ways could they finish? It would just be 5 factorial, and typically that would give you the total. If you think about it, as 5 swimmers dive in, 5 of them could have come first and 1 of them comes first. So then how many could have come second? 4. And so that person's come second. How many are left to come third? 3, 2, 1. One method I find really helpful that's changed the game for the students that I teach is what I call the zoom in, zoom out method, whenever there's groups or clusters of something. And so let's just say there's 8 people, there's 3 men and 5 women. How many ways could they sit? It would just be 8 factorial. I haven't put any restrictions on it, so it's just they could sit in any order. What's the probability of if men and women sit separately? And so what you do is you zoom into just the men. So if you look just at the men, there were 3 of them, so they could sit in 3 factorial different kind of ways. I zoom into just the woman, and the women as a group could sit 5 factorial different kind of ways, as if they're their own little baby question. But the missing key that people often forget is that you need to then zoom out and say, how many groups did I have? And there's 2, there's men and women. And so if you picture them coming into a classroom, the men could, at this stage, if I just stopped here, the men are sitting together in a bunch of different ways, and the women are sitting together in a bunch of different ways. But the men could be sitting on the left and the woman on the right. But once I do zoom out and I realize there's 2 groups, I do 2 factorial, then it means that where they sit, left and right, could swap around as well. And so don't forget to always do that, and I always put it over the total. So let's think of that with specific names. What's the probability that Tim, Jane and Kelly will always sit together? So that's 3 people. So I zoom in, and there's 3 of them, and then I zoom out, and it helps to almost use your fingers. Picture that you've got your 8 fingers, and the 3 of them, because they're always sitting together, they count now when I zoom out as if they're one entity. So I've got 5 individuals, and then I've got the group of 3. And so when I count, if this was my artistic fingers, 1, 2, 3, 4, 5 individuals and 1 group. So it's 6 that are moving parts. So that's why it's times 6 factorial, and it's always over the total. One last one. Maybe you have a couple, Yanni and Josh, that are sitting together, and so you zoom into their coupleness, and it's 2 factorial because there's 2 of them that could sit left, right, or right, left. And then you zoom out. So we've got 1, 2, 3, 4, 5, 6, 7, 8 people, but 2 of them are always wanting to sit together. And so when I zoom out, I count them as one entity. 1, 2, 3, 4, 5, 6, one entity, 7. And that's why it's times 7 factorial. And that's how we get our answer. So I hope that zoom in, zoom out method changes your life for probability. If you found this video helpful, please like it, subscribe to our channel, and share this with your friends. Thanks.